this is a review of the definite integral, but it's kind of a nifty thing. When we found the area from A to B, we found the area from 0 to B of f of x dx, and then we found the area from 0 to A, and what did we do to find this area in here? We subtracted them, right? So apparently this is the same as f of x dx. This is the same as adding what to what of f of x dx? What if you take the opposite, what do you do with the boundaries? Flip them, right? So this is really negative, or this is a to 0, right? This is a to 0. So if you're going from A to 0, then 0 to B, what is this combined f of x dx? What's that? Yeah, it's just A to B. That's the fundamental theorem. See how I did that? Kind of makes sense. Does this work, though, if A is less than 0? Does that still work? Does it? Can I still go f of B minus f of A? And the answer to that is yes, it does work. But here's what's kind of interesting. When you go from A, and this is a negative answer, negative A to 0, here's kind of what happens. You're still going from 0 to B, right, to get this area. And then when you're going from here to here, it's kind of reversed, like this. Right? And so when I go from 0 to B, f of x dx, and then when I reverse it, it's going to be negative a to 0, f of x dx. You can see that this still gives me negative a to b f of x dx. So, okay, let's give you a little comfort. All you have to do is integrate it. It doesn't matter which quadrant you're in. It works above the x-axis. So just go ahead and do it like normal. But that's why. For integration and antiderivatives, did we talk about the format for the antiderivative? How do you just take the antiderivative of x cubed? What do you do? What do you do to find it? I know what to do for the derivative, 3x squared, but what about the antiderivative? You add 1, and then you divide it by that, plus this constant c, and we'll figure out what that means. So it's x to the 4th over 4 plus c. So this is what we call the antiderivative of f of x. Well, no, we're finding the antiderivative. Okay, now, what if you took the derivative of this? What if you took the derivative of this thing?
Excuse the interruption.
Yes.
Is Gabby Evans in class?
She is.
Please have her go see your guidance counselor whenever possible.
Okay.
Thank you.
So if we take the derivative of x to the 4th, what is it? 4x cubed divided by 4. It's just a constant, 1/4. 1/4 times 4x cubed is what? X cubed. What's the derivative of like 7? 0 plus 0. Did we get the original function? Yes, we did. And so that's kind of cool. It's reversible. And that's what the fundamental theorem part A was about. You take the derivative of the antiderivative. But what I wanted to show you is that if you wanted to take something like the square root of x, rewrite it, f of x, as x to the 1/2. Don't leave it square root. It's too confusing. if I want to take the antiderivative of x to the 1/2, this is going to be what? X to the, raise the power by 1, 3/2 and divide by 3/2. And most of the time, you're going to see me multiply by 2/3, x to the 3/2 plus c. Let's try one more. Antiderivative of x, 1 over x to the 4th. Is that very helpful to see it that way? No. So we'll rewrite it as x to the negative 4. And then we're going to raise the power by 1, right? So you're going to get x to the negative 3rd over negative 3 plus c. That's it. That's the antiderivative of that. So anything that has a single will be easy. You just write it as a power, and then raise the power by 1 and divide by that. That's the antiderivatives. Okay? And now, we're going to build into the u sub. We're getting to it. And so they do a cool thing here is they have you take the derivative, and then from there they try to find the antiderivative. So I don't like their example very much. But just a couple things. Here are some that we've talked about. Antiderivative of a constant. Oh, what's the antiderivative? What's the antiderivative of 5? What? How'd you get that? How'd you get the antiderivative of 5 was 5x? Well, what's the derivative of 5x? That's 5, right? Now, wouldn't it be cool if I could do some magical way of helping you understand it just instead of just having to memorize that? I do. This is the same as 5x to the what? Close. 0. X to the 0 is 1. Now, pull this constant 5 out in front. What is the antiderivative of x to the 0? Do the trick. X to the raise the power? 1 over? That's cool, isn't it? Okay, so math does make sense. You don't have to memorize things ridiculously, but that's what the first part was. If the derivative of e to the x is e to the x, what do you think the antiderivative of e to the x is? E to the x. If the derivative, and probably the most important one on here, oh, thanks for not smirking at that. That's the derivative of that. What's it do? 1 over x, yeah? So what do you think the anti of 1 over x dx is? Natural log of x. Tough one. We'll use it all the time. A lot. And then we'll get to these. These are kind of obvious too. All right, good. So we're ready to go to the assignment. So the assignment today is to practice Archimedes for the quiz tomorrow. Seniors, you're going to have the quiz tomorrow, and the juniors. And then for Wednesday, I think we're going to do a little bit of U sub. And then we'll finish those problems in class. I'll show you tomorrow what it's going to be, so you don't have very much homework. Let's just do number 1. Let's just do a bunch of these together, and then you'll see how easy they are. So what's the derivative? Well, let's talk this form business first. Y equal x to the 7th. Okay? What's another name for y? F of x, right? Okay, so a couple ways to do the derivative. Sometimes they'll call this the derivative. By the way, what's the derivative of x to the 7th? 7x to the 6th. Now, some of you integrated, and that's what I think is the hard part of integration is which do we do, you know? And sometimes we do them both in the same problem, which is why U sub is so hard, but you'll get it. Okay, another thing you could do is you could call this f prime of x, because y and f of x are the same. You get the same thing. There's one other one that I want you to be aware of, and that is you could do a d dx of f of x, And that is the same thing as 7x to the 6. All three of these mean the same thing because y and f of x mean the same thing. This is a new one. It has to do with differential equations that we'll get to later. Oh, one other. You could also, what's f of x the same as? Y. So this is the fourth way. All of these are the same. Y, y prime, f of x, f prime of x. D dx of f of x, d dx of y, those mean the same thing. So now, if you go to, so d dx of x to the 7th is 7x to the 6th. So, what do you think the antiderivative of x to the 6th is? Yeah, it's going to be x to the 7 over 7, right? Plus c. Now, what's different here? What's different here is that with this, it looks like this one, except here we didn't have the 6. So, you know, you're gonna have to deal with this 1/7 and this 7, which we'll get to. Take a look at this one, number 2 here. What's the derivative of x cubed plus x squared? I'll be interested. What do you get? 3x squared plus 2x. So what's the antiderivative of 3x squared plus 2x? Yeah, it's 3x cubed over 3, or x cubed, 2x squared over 2, or x squared, plus c. Now this one's nice. It looks just exactly like the original, doesn't it? Because we had the derivative. Why is this one not the same as the original?
Because it
Didn't have the 7 next to the 6th. Okay, that's going to be important when we do this next one. Next one is, what's the derivative of e to the 2x plus 1? Careful, what's the derivative? 2 times e to the 2x plus 1. Now, do you see that this is different than e to the 2x plus 1 that we're integrating here? Do you see that it's different? Yeah. So we're going to get e to the 2x plus 1, but what's it missing? It's missing the 1/2, so this is going to be a 1 over 2 plus c. Same reason that this one was missing the 7, so that's why they divided by 7. How are you doing? Okay? All right, and then let's do 4. D dx of 2x plus 1 to the 4. There's a Tootsie Pop rule in here. I get it. 2x plus 1 times 4, drop the power 1, and then what do I multiply this by? By 2. Yeah. So this is the same as 8 times 2x plus 1 to the 3rd. And now when I see this one here, what don't I see? I know that this is going to be equal to 2x plus 1 to the 4th over 4, but there's something that I don't see that I'm going to need. The 2, yeah. You're going to need a 1/2 in there. How many of you think that this is right? How many think it might not be right? How could you check? Take the derivative, see what you get. Yeah. What x times the square root of x? That's x to the what power? Yes. Isn't that easy now? What's the derivative of that going to be? 3 halves x to the 1/2. Okay? So what is this antiderivative going to be of x to the 1/2? What's that going to be? That's going to be, yes, it's x to the 3 halves over 3 halves or times 2/3. Let's see. So I love this rewriting technique. Super, super powerful. Don't leave them like that. Rewrite them.